In our lesson today, we're going to look at what we call some trigonometric identities. And if you remember from algebra, an identity was simply an equation that was true for all values of x. So in this case, since we'll be dealing with angles, these are equations that are true for all angle values. It doesn't matter what our angle is, the identity would be true. And we can use that then as we're solving. Now, we're going to look and develop these identities based upon our trigonometric definitions that we looked at in the previous lesson, in which case we have that the sine of theta was equal to y over r, cosine of theta is x over r, tangent of theta is y over x, the cosecant of theta is defined to be r over y, the secant of theta is r over x, and the cotangent of theta is x over y. These are our trigonometric definitions. So we want to take these definitions and from them we want to develop some of our identities. You will need to memorize these identities, and we can use them in a lot of different ways, especially we can use them for simplification to make some of our expressions a little bit easier to work with. The first set that we're going to look at are called the reciprocal identities. And so they're going to be based upon reciprocals. So let's look at how that we develop these, and then we will deal with those. We know by definition that the sine of theta is y over r. Now, back in arithmetic, you learned that when you have a fraction, as long as you do the same thing to both the numerator and the denominator, that you can do just about anything that you want to. And so we're going to take this and we're going to divide both the numerator and denominator by y. You can do that as long as y is not 0. And we're talking about a point on the terminal side of an angle. So let's divide both our numerator and denominator by y. Well, we know that y divided by y is 1, and we know by definition that r divided by y is cosecant. So what we found is that the sine of theta is equal to the reciprocal of the cosecant of that same angle. It would work if we started with the cosecant, and let's do that. And the cosecant is r over y. And in this case, let's divide both the numerator and denominator by r. Well, r divided by r is 1. Y divided by r is sine. So these are called reciprocal identities. The sine is the reciprocal of the cosecant, and the cosecant is the reciprocal of the sine. So we could start with that one, and we could have that the cosecant of theta is equal to 1 over sine theta. And this is the way that we'll use it most often. We could also say that the sine of theta is equal to 1 over the cosecant of theta. Now, if we went back and we looked at some of our other functions, let's say that we wanted to start with cosine. So the cosine of theta is equal to x over r. And again, let's divide both the numerator and denominator by x. So we end up with 1 over r over x, and r over x is equal to the secant. If we started with the secant of theta, which is r over x, and we divided both the numerator and denominator by r, then we have 1 over x over r is cosine. So this is another way of showing that secant and cosine are reciprocals of each other. So we can put here that the secant of theta is equal to 1 over the cosine, or that the cosine of theta is equal to 1 over secant. More often we will change secant to cosine than we would cosine to secant. And then if we want to look at the tangent and cotangent, the cotangent is defined to be x over y. And so let's take this and let's divide both the numerator and denominator by x. So we get 1 over y over x, which is tangent. And if we started with tangent, then tangent is y over x. And let's divide both of these by y. And so we end up with 1 over x over y, and x over y is cotangent. So these are what we call our reciprocal functions. And we will put here then that the cotangent is equal to 1 over the tangent. And then that also means that the tangent is equal to 1 over the cotangent. But as we said, most of the time we will change cotangent to tangent and secant to cosine and cosecant to sine. And that's the way that we will deal with these most often, not changing sine to cosecant. So we have what are called our reciprocal identities. Okay, we also have what are called our ratio identities. So we want to look at those, and so these will be our ratio identities. And let's see how we develop them from our formulas. Okay, let's start with the tangent. And we're going to develop this one a little differently. It's going to come up with a different identity. But we know that the tangent of theta is equal to y over x. And let's divide both our numerator and denominator by r. As long as you're dividing by a non-zero number, you can divide both your numerator and denominator by the same thing. Well, y over r is equal to sine. X over r is equal to cosine. So the tangent is also equal to the sine of theta divided by the cosine of theta. If we dealt with the cotangent, well, it's x over y, and let's divide each one of those by r. So x divided by r and y divided by r would give us cosine of theta over sine theta. So here's a way of expressing tangent and cotangent in terms of sine and cosine. So our ratio identities tell us that the tangent of theta is equal to the sine of theta over the cosine of theta, and the cotangent of theta is equal to the cosine of theta divided by the sine of theta. Now we want to look at some of the ways these can be used, and what we're about to do can be done in several different ways. We don't have to use our identities, our ratio identities to do this, but at this point we want to just to practice and to get to learn our identities a little bit better. So let's say that we're told that the sine of theta is equal to -3/5. and that the cosine of theta equaled 4/5. What we want to do is define the tangent. Well, the tangent of theta is equal to the sine of theta over the cosine of theta. So that's equal to -3/5 divided by 4/5. We have a complex fraction. So in algebra, we learned that our denominators would cancel, which will leave us with -3/4. If you've forgotten that and you're not sure what to do, then you can go back to arithmetic that -3/5 divided by 4/5. To divide by a fraction, you multiply by the reciprocal, which would be 5/4. So our 5's would cancel and we would end up with -3/4. Now, if the sign is negative, let's just see if some of this makes sense. If the sign is negative, that means it's either in quadrant 3 or 4. The cosine's positive, so that's quadrant 1 or 4. So that means that our angle here is in quadrant 4, and in quadrant 4 the tangent is negative. If we wanted to find the cotangent, well, cotangent is equal to the cosine over the sine. The cosine is 4/5. The sine is -3/5. Our 5's are going to cancel, and we have -4/3. So our identities help us then, as we go through, to be able to find our functions. And so that's one of our uses for that. Okay, and then this is just a note for arithmetic before we move on. This is a notation thing. And then we're going to look at what are called our Pythagorean identities. But one of our notations, if we're talking about squaring a function, then most of the time we're going to write this as the sine squared of theta. Now this means we're squaring the function, and remember, sine doesn't have any meaning without an angle. This is the same as the sine of theta squared. And if you're using your calculator, then you're going to have to put it as the sine of theta in parentheses squared. And so these two are equivalent, and they do not equal the sine of theta squared. This means we're squaring the angle. Remember, we follow our order of operations, so if we're just dealing with this, it's saying we're going to take the angle, square it, and then take the sine of that angle. Up here, this means we're going to take the sine of the angle and then square it. And so if we had this, then if the sine of theta equals 3/5, then the sine squared of theta equals 9/25. If we square one side, then we square the other side. So this is just a notation note so that can help you as we start looking at our next set of identities. And these are ones that are very important that we will use quite often. And they're going to be what we call our Pythagorean identities. Our Pythagorean identities we use quite a bit, and as I said, they become very important. Let's start with the idea with the Pythagorean theorem, and you would get that idea. These are called Pythagorean identities, that x squared plus y squared equals r squared. Now, as long as we do the same thing to both sides of the equation, we can do anything we want to except divide by 0. So let's take this, and we're going to divide both sides by r squared. So I'm going to go ahead and distribute that division on this side. And have x squared over r squared equals r squared divided by r squared. Now this is the same, x squared over r squared from algebra we learned is the same as x divided by r squared. This is the same as y divided by r squared. And r squared divided by r squared would be 1. This is cosine, and since it's squared, this is the cosine squared theta plus sine squared theta equals 1. And this is our Pythagorean identity. And most of the time when you see it, you're going to see it as sine squared plus cosine squared, which is simply our commutative property. Now, with each of these Pythagorean identities, with the main one, we also have some variations. We could take this and subtract cosine squared from both sides, so we would get that the sine squared of theta equaled 1 minus cosine squared. Or we could subtract sine squared from both sides and get that cosine squared theta is equal to 1 minus sine squared. You need to memorize that sine squared plus cosine squared equals 1. And you need to quickly recognize or know then that sine squared theta equals 1 minus cosine and cosine squared theta equals 1 minus sine squared. So let's add some of our Pythagorean identities. And I'm just going to go ahead and write it as sine squared plus cosine squared equals 1. Now, I'm not going to put the other two with it, but you do need to know them. Okay, let's go back and let's take our Pythagorean identity again. X squared plus y squared equals r squared. And this time, let's divide everything by x squared. So x squared divided by x squared, we're going to distribute it, equals r squared divided by x squared. Now, again, x squared divided by x squared is 1. We know this is the same as y over x, which is tangent. So this would be tangent squared. And r over x is secant. And it would be secant squared theta. So here is another Pythagorean identity based upon the tangent and the secant. Now notice that the tangent has to be squared and the secant has to be squared. Again, we can come up with some other ways. We could say, well, the tangent squared is equal to secant squared minus 1, subtracting 1 from both sides, or 1 equals secant squared minus tangent squared. So that gives us a second Pythagorean identity. That 1 plus tangent squared equals secant squared. And then the last one that we want to look at, let's go back with our Pythagorean theorem. Start with x squared plus y squared equals r squared. And this time let's divide everything by y squared. Oops. So x over y is cotangent plus 1, and r over y is cosecant. And again, we could subtract 1 from both sides, so cotangent squared equals cosecant squared minus 1, and subtracting cotangent from both sides, then 1 equals cosecant squared minus cotangent squared. So we have our Pythagorean identities. And we'll just add those. So we have this last Pythagorean identity, which says that the cotangent squared plus 1 equals the cosecant squared. Now these give us what we call our fundamental identities, and from them we can do a lot of solving, and more than that, especially in the next lesson, we'll look at how we can do them for simplification. But what you're going to do are some exercises that help you learn these identities and to know them a little bit better. And I'm not going to try to tell you that this is the easiest way or the way that you will always do it. It is just a way. And one of the things we'll find in Trig is that there's a lot of different ways to do things, and so you can do it the way that you see it as long as you have justification for doing it. So let's look at some problems that we've already done by using the definitions of our trig functions, and let's solve them using our trigonometric identities. So we're going to start out and we're going to be told that the sine of theta is equal to, or let's find the sine of theta. Let's find out what it does equal. So the sine, we want to know what the sine of theta equals if we're told that the cosine of theta equals 5/13 and that theta is in quadrant 1. It simply means, so we know then that's going to help us with the positive and the negative. Well, if we go back, cosine is x over r. So we know that x is equal to 5 and r is equal to 13. Now you might remember your Pythagorean triples. We have a 5, 12, 13. Remember, the hypotenuse has to always be the longest. If you don't remember that, then you go back that r squared is equal to x squared plus y squared. So r's 13. 13 squared is equal to 5 squared plus y squared. 169 equals 25 plus y squared. And subtracting 25, 144 equals y squared. Then we take the square root of both sides, so we get plus or minus 12 equals y. Well, we have to know, is it the plus or the minus? That's where we use that it's in quadrant 1. In quadrant 1, y is positive, so it's going to be the positive 12. And this is how we solved it in the last section. And so we could go back and we could say, well, the sine is y over r, which is 12/13. Now, what we want to do here is do this by using our Pythagorean identities. And as I said, this is how we solved it in the last section, and this is probably the easiest way. But let's use our Pythagorean identity so that we can justify, or in our mind, that the Pythagorean identity works. So our Pythagorean identity says that the sine squared plus the cosine squared equals 1. Well, if we're wanting to know what sine squared is, then sine squared equals 1 minus cosine squared. So there's that Pythagorean identity. We know that the sine squared, we don't know the sine squared, we know that the cosine squared is 5/13. And now it's arithmetic. So 1 minus 25, 1/69. So this is 169, 1/69 minus 25, 1/69, which equals 144, 1/69. Now that's what the sine squared equals. So if we take the square root of both sides, we get that the sine is equal to plus or minus 12/13. We have to go back. We're in quadrant 1. So in quadrant 1, the sign is positive. So the sine of theta equals positive 12/13. And since we did it the other way also, then we know that we got the same answer both ways. So it's a way of using it. And what the advantage of using your Pythagorean identity, we didn't have to go back and solve for y. We knew the cosine and we had an identity, and so we could do that. Okay, let's look at another one. And this one we'll only do using the Pythagorean identity. Let's say that we want to find the cotangent of theta. What we're told is that the sine of theta is 2/3, and theta's in quadrant 2. Well, we want to think back. Cosine and sine. If we went back to our Pythagorean identities, I don't think we had one that dealt with cosine, with cotangent and sine. We had sine and sine. We have tangent and secant. Here we have a cotangent. Cotangent's what we're trying to find. And we have a cosecant. Well, cosecant is 1 over sine. So we do have a way that we can take our sine then and deal with it. So let's go back now and look at this, of what we're going to do. Since we're given the sine and we want to find the cotangent. So if we go back and we start with our identity for cotangent, we know that 1 plus cotangent theta, cotangent squared theta, equals cosecant squared theta. Well, cosecant is the reciprocal of the sine. It's 1 over the sine, or it's the reciprocal. And so we can say then that the cosecant of theta would be 3/2, and that's what we want to square. So we have 1 plus cotangent squared equals the cosecant, which is the reciprocal of sine. Now if we solve this for cotangent, we're going to have 3/2 squared, which would be 9/4 minus 1. So the cotangent squared theta equals 9/4 minus 4/4, which is 5/4. Well, that's the cotangent squared. We want the cotangent, so we're going to take the square root. We'll say plus or minus the square root of 5/4. Well, we can't take the square root of 5, but the square root of 4 is 2. Now, we have to decide, is it the plus or minus? So we go back, we're in quadrant 2. In quadrant 2, cosine is, or cotangent is negative. If you remember, they're all positive in quadrant 1. The sine and its reciprocal is positive. In the third quadrant, the tangent and its reciprocal. In the fourth quadrant, the cosine and its reciprocal. So we're in quadrant 2. The sine's positive, but all the others are negative. So the cotangent would be the negative square root of 5/2. Let's do another one. And let's say for this one, we're told that the sine of theta equaled negative 3 over the square root of 10, and that theta is in quadrant 3. Now, another way of writing that is saying theta is an element of quadrant 3. Okay, what we want to do here is find all of our other trig functions. And we want to do each one by using one of our identities that we've learned here. We don't want to go back to the definitions. In this case, we want to use the identities. So let's start out with cosine. We know that sine squared plus cosine squared equals 1. So the cosine squared equals 1 minus sine squared. And you should know this enough that you could go directly to that identity and not have to derive it from the main one. But if you forget it, then go back to your main one. So the cosine squared equals 1 minus, and sine is negative 3 over the square root of 10, and we want to square that. So that's 1 minus. Now a negative squared is a positive, 3 squared is 9, square root of 10 squared is 10. So we have 10 tenths minus 9 tenths, or 1 tenth. And that's what the cosine is, cosine squared is. Well, taking the square root of both sides, then the cosine is equal to plus or minus the square root of 1 tenth, which is the square root of 1, which is 1 over the square root of 10. We have to decide if it's positive or negative. Well, we're in the third quadrant. In the third quadrant, cosine is negative. So now we know the sine, we know the cosine. We can find our reciprocal ones. The cosecant of theta is equal to 1 over sine of theta. So the cosecant of theta is equal to 1 over, and the sine of theta was negative 3 over the square root of 10. So we have the reciprocal of this, which would be negative square root of 10 over 3. If we wanted the secant of theta, well, the secant of theta is equal to 1 over the cosine. And we found out that the cosine up here was negative 1 over the square root of 10. So it would be the reciprocal negative square root of 10 over 1, which would be negative square root of 10. Now for the tangent of theta is the sine of theta over the cosine of theta. The sine of theta was 3 over the square root of 10, and that was negative. The cosine of theta was negative 1 over the square root of 10. Again, if your denominators are the same, they cancel. We have 3 divided by 1, which is 3. A negative divided by negative is a positive. The cotangent of theta is cosine over sine. So it would be negative 1 over the square root of 10 divided by negative 3 over the square root of 10. Well, our denominators cancel. We have 1 over 3, and a negative divided by a negative is a positive. So here we have all 6 of our trig functions using our basic identities, or what we also call our fundamental identities. And one last thing that we want to look at is doing this with a calculator, and I would not always, this is not necessarily the way that we're going to use the calculator to do this, but it's just showing you that you can still find these if you're given an approximation. So let's go through and let's say that you're told that the cosine of theta is equal to 51 hundredths. We're going to round all these off to 2 decimal places. And theta's in quadrant 1. So that means they'll all be positive. Okay, we know that the sine squared plus the cosine squared equals 1. So sine squared equals 1 minus cosine squared. So the sine of theta, sine squared theta, is equal to 1 minus 51 hundredths squared. And if you wanted to go ahead, since we're going to use the calculator, the sine of theta is going to equal the square root of 1 minus 51 hundredths squared. Now you can put all of that into your calculator and go through and do that. If we pull up our calculator, then we're going to have the square root of 1 minus and 51 hundredths, so 0.51 squared, then close our parentheses and enter. I'm not sure why I'm on the plot, except that's what showed up when I started. So let's just clear all that out. Never even noticed that I didn't have a blank screen. So 1 minus 51 hundredths squared, close the parentheses, enter. And then if we round that off to 2 decimal places, we'll have 86 hundredths. So the sine of theta will equal to the nearest hundredth 86 hundredths. So now we know the sine and the cosine. We can do the reciprocals. The secant of theta is equal to 1 over the cosine. So the secant of theta is equal to 1 over 51 hundredths. And if we go to our calculator on this, now there's several ways that we could do this. We could actually put 1 divided by 51 hundredths and come up with 1.96 rounded to the 2 decimal places. Or you could use your reciprocal key. This x to the negative 1 is the reciprocal, so you could put 51 hundredths, hit the reciprocal key, and then enter, and it will give you the same thing. So that's another way of getting that. So we have that the sine of theta is equal to 1.96, or 1 in 96 hundredths. We could do the cosecant of theta is equal to the reciprocal of sine, and sine was 86 hundredths. So we would get then that that was equal to and if we just say 86 hundredths reciprocal, so that's equal to 1 in 16 hundredths. So we have cosine, sine, secant, and cosecant. So our tangent is equal to the sine over the cosine. So tangent would be equal to sine, which is 86 hundredths, over the cosine, 51 hundredths. Go to our calculator. We would have 86 hundredths divided by 51 hundredths. So that would be 1.69. And the cotangent of theta is the cosine over the sine. Well, our cosine was 51 hundredths. Our sine was 86 hundredths. Going to our calculator, we have 51 hundredths divided by 86 hundredths, or 59 hundredths. So you can use your identities along with the calculator and come up with approximations. Now, as I said, there are some other ways that we will do this that are a little bit more direct and possibly easier to do, but mainly what you're needing to do here is to become familiar with your basic identities. These you need to know by memory. Your reciprocal identities, cosecant of theta equals 1 over sine, secant equals 1 over cosine, cotangent equals 1 over tangent. Your ratio identities, that the tangent is equal to sine over cosine, cotangent's equal to cosine over sine. And then your Pythagorean identities, sine squared plus cosine squared equals 1. And along with that, then you would know that cosine squared equals 1 minus sine squared, and sine squared equals 1 minus cosine squared. 1 plus tangent squared equals secant squared, and then there's two other variations of that. And cotangent squared plus 1 equals cosecant squared. Okay, in the next lesson, what we're going to do is look at a little different way of using these identities and using them for simplification.